Hi, in the last session, we talked about the VHDL arithmetic operators and we learned that how to use them in VHDL. Now in this session, we will understand the concatenation operator and we will see that how this is important for vector and array data types. So let's start. First, we will see its symbol in VHDL. It is and sign. In the US keyboard, it is Shift plus 7 key. In VHDL, this is concatenation operator, and this will allows you to create a large array from two or more smaller array or elements. Physically, you can think of concatenation as merging two datasets to create a larger one. Simple. You can use this operator with the std underscore logic underscore vector data type or bit vector data types. And you can also use this with signed and unsigned data. But make sure that the assigner and the assignee both should have the same data elements to use this operator. If they are not same, then you may see the compilation error. So make a note of that. You will need to use std underscore logic underscore 1164 package to use the concatenation operator in VHDL. Let's understand this in details with some examples. So here you see some examples. First, we have declared four signals. All four signals are std underscore logic underscore vector type, but having the different length. Like signal A has 4 bits, signal B also has 4 bits. These two signals, like signal A and signal B, are assigned with some initial value. And these are 1011 for signal A and 0110 for signal B. We also have signal C, which has 6-bit data, and signal T, which has 8-bit data. So I will quickly read this declaration here. So I have written that signal A colon std underscore logic underscore vector 3 down to 0 colon equals to 1011 semicolon. Signal B colon std underscore logic underscore vector 3 down to 0 colon equals to 0110 semicolon. Signal C colon std underscore logic underscore vector 5 down to 0 semicolon. Signal D std underscore logic underscore vector 7 down to 0 semicolon, right? And now we have three examples. In the first statement, C gets the value of 0 and signal A and 0 semicolon. Remember the value of signal A, this is 1011. So we have first concatenated 0 with signal A, so it becomes 0 1011. And now we again concatenated this value with 0 in the last. So the final value will become 0, then 1011, then 0. So the final value is 0 10110 will be assigned to signal C. Now the most important thing is that A has 4 bits and we added 1 bit in the start and 1 bit in the last. So it becomes 6-bit data. Hence, the target signal must have std underscore logic underscore vector data type with the length of 6 bits. Like here, our signal C is 6-bit in length. In case it is not matched with the 6-bit length, then this statement will give you the compilation error. Let's look for the another example. So C gets the value of 1, concatenation A, concatenation B, 0, semicolon. So let's decode this statement. So here C is 6-bit std underscore logic data. We added hard-coded 1 at the very start. Then we added signal A, which is the 4-bit data. And in the last, we added B, 0. This is 1-bit data of signal B at the 0 index. Hence, the final output would be 1, then signal A data, which is 1011, and in the last B0, which is 0. So the output will be 1 1011 0. Now the last example, this looks very straight. So D gets the value of E and B, semicolon. This AND is concatenation operator. So we concatenated signal A and signal B. And because both of these signals are 4-bit long, so we will have the total 8-bit data. This means that signal D must be 8-bit in length. So you can see that we declared signal D as 7 down to 0, and this is 8-bit in length. So we first added signal A data, which is 1011, and then it is merged with signal B data, which is 0110. So the output will be 10110110. So this value will be assigned to signal D. Okay, so by now we have discussed all these listed operators here supported by VHDL. We covered multiple examples and demos to understand them and their functions. And now we know that how to use them as well. But still, we need to use them very carefully, especially when you are writing the statements by combining multiple operators in the single statement. In such cases, VHDL follows the operator's precedence to perform the actions. And if you do not follow the right precedence label, then you may not get the expected output. Hence, in the next session, we will be covering operators precedence in VHDL. So don't miss out the next session, because I will also tell you the best practices when you need to use multiple operators in one single statement so that you get the right results for your designs every time. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.